So this video is going to talk about determining a rate of change. A rate of change is one of the most important things that we'll study in algebra this year. So what is a rate of change? Well, as you see, it's how one variable changes with respect to another. So a couple of examples are things like miles per hour. So if we're measuring the rate of change for miles per hour, we're determining how do the miles change each hour. Another example, how do the points that a person may score change each game? Or one of my favorites, how many gallons does your toilet bowl use each flush? So there's a lot of different ways we can represent a rate of change. Let's see a few. So you see a pattern here. It looks like it's a pattern made out of toothpicks. If you want to grab toothpicks, you can. If not, if we just want to draw them, that's fine. It looks like I have figure 1. And then figure 2 builds upon figure 1. And then figure 3 builds upon figure 2. So take a minute or two and draw the next 3 figures. Okay, so I'm going to start with what figure 3 looked like. It looked like figure 3 looked something like that. And then to add on to it, it looks like I'm going to need to put another triangle. So I'm going to build that side there and that side there. So it looks like that's going to be figure 4. So now if I take figure 4, which looked like this, and then add onto it again to build figure 5, I might do something like that. There's figure 5. And again, starting with figure 5, we can build figure 6. So that looks like what figure 5 is. And then we're going to add toothpicks to make figure 6. So our pattern making is done, but let's take a look at some of the results of it. So let's complete the table for figures 1 through 6. So if you look back at figure 1, it was made of 3 toothpicks. Figure 2 had 1, 2, 3, 4, 5 toothpicks. Figure 3 had 7. And then when you made figure 4, it would have a total of 9 toothpicks. And then figure 5 would have 11, and figure 6 would have 13. So what you've just generated is called a sequence. A sequence is a list of numbers that follow a rule. So there's a certain rule that generates a sequence. If we look at this sequence, what was our rate of change? How did our toothpicks, the total number of toothpicks, change each new figure? Well, it looks like just from our table, we went from 3 to 5 to 7. It looks like we added 2 each time. And sure enough, if you built it with toothpicks, or if you just added onto your figure, you drew 2 new segments each time. So the rate of change is going to be 2 toothpicks for each figure. And I should probably change that word each to per. We like that word per for the rate of change. It's how many of these per that. So each new figure, we need 2 new toothpicks. So then how many in the 10th figure? Oh man, do we have to draw figure 7, 8, 9, and 10? Well, not if we know the rate of change. So we knew figure 6 had 13 toothpicks. Well, figure 7, we'd add 2 more and get to 15. Figure 8 would have 17. Figure 9 would have 19. And figure 10 would have 21. So knowing our rate of change can help us figure out additional terms as well. So take a look at another scenario. Now we're going to be in a car and we're going to be driving from Albany out towards Buffalo. So the car's distance in miles from Albany after every hour is given. So maybe you're sitting in the back of the car and after the first hour, how far are we from Albany? We're 66 miles. How far are we from Albany after 2 hours? 132, and so on. Can you determine this car's rate of change? So if we think about the rate of change for a minute, we want to know how many miles is this car traveling every hour. So it looks like if I find this rate of change, it looks like I'm going up an additional 66 hours because or 66 miles, because 132 minus 66. The change here is 66. And if I continue, 198 minus 132 is going to be another 66. So notice every hour, every time our hours increase by 1, our miles change by 66. So our rate is 66 miles per hour. It sounds like that's how fast the car is going. And a matter of fact, speed is one of the most commonly used rates that we'll deal with. All right, so let's use what we know. It says here that I have 3 different sequences of numbers, and I got some blanks filled in. So let's determine the rate of change for each sequence. And after we determine that rate of change, let's fill in the missing terms. Why don't you try the first one? So let's see, what's our rate of change? It looks like to go from 7 to 12, I'm adding 5. From 12 to 17, I'm adding 5. A sequence follows a rule. It looks like this sequence is adding 5 each time. So if I add 5, I get 22. 27's there. Plus 5 is 32. Plus another 5 is 37. And just to make sure, 37 plus 5 is 42. So that kind of makes sense. It follows the pattern. You tried the second one. So what I notice here is that I know these 2 consecutive terms. I know the 14 and the 19. Well, how do I change from 14 to 19? I add 5. So that's going to help me going forward. 19 plus another 5 is 24. But what do you think we would do to go back? Hey, if you said subtract 5, that's pretty good. Because I know that whatever this term is here, if I added 5 to it, I get 14. So if I subtract 5, I get 9. So it looks like I'm going backwards here, 5. Subtract another 5 to 4. Subtract another 5 to negative 1. Looks pretty good. You tried the third one. Oh, did you think that the rate of change was 5? Oh, it's not 5. Well, I have my 2 consecutive terms here, though. So if I know those 2 terms, let's figure out what the rate of change is. To go from negative 11 to negative 15, we're subtracting 4. So if I want to go to the right another term, if I subtract 4 from negative 15, I get negative 19. So what we just realized was that if we want to go to the left, we have to be adding, or we have to do the opposite of our rate of change. So instead of our rate of change being subtract 4, let's add 4 and get negative 7, negative 3, positive 1. I got to add another 4 to get to positive 5. Now, you might be saying to yourself, hey, I've seen this before. Yes, there's another word for rate of change. Have you ever heard of it before? Starts with an S. Rhymes with lope. Rate of change is a slope. Yes. You've probably heard of rate of change before. You've probably heard of slopes before. Slope. The change in the output. The change in Y. Divided by the change in the input. The change in the X. Exactly. Maybe you've seen things like Y2 minus Y1 over X2 minus X1, where X1 and Y1 are points, X2 and Y2 are points. Maybe you've seen that before. Exactly. So if I want to find the rate of change here, when I'm looking at this table, I'm going to ask myself, well, how are the Y values changing? Maybe I'll pick the difference between 2 Y values. So if I go 5 subtract 8, I'll get negative 3. And then if I subtract the X values, 2 minus 1 is 1. So my rate of change here, my slope, is going to be negative 3 over 1. And notice that it would continue regardless of the values we chose. Let me do this one in green. Suppose we went here, 2 minus 8 is negative 6. If I go here and get 3 minus 1 is 2, my rate of change could also be negative 6 over 2. Either way, the rate of change is negative 3. Every time x increases, the y goes down by 3. Yeah, I think you've heard of slope before. That's great. So this is a nice lesson on rate of change, how to find it from a table, how to follow a pattern. Great work.